Okay, next example. It says list all possible rational zeros of this fourth degree polynomial. So let's start off with finding all possible factors of 10, which will be our p's. Sorry, I shouldn't say possible. These are factors of 10, our constant term. I know I'm going to use 1 and 10. 10 divided by 2 gets me 5. So 2 and 5 go on the list next. Next number up from 2 is 3. 10 divided by 3 gets me decimals. So I know it's not divisible by 3. 10 divided by 4 also gets me a decimal. So we know that 10 is not divisible by 4. Next number after 4 is 5, which is already on our list. So we're done with our values for P. Q, I apologize. Q is going to be our factors of our leading coefficient, which is 1. Remember, if it's not there, it's a 1. And the only factor of 1 is 1. So if we're looking for all of our possible rational zeros, plus or minus P over Q, we're going to take 1, 2, 5, and 10, divide by 1. 1 divided by 1 is 1. 2 divided by 1 is 2. 5 divided by 1 is 5. And 10 divided by 1 is 10. Keep in mind that you may be asked to write these out individually. So you may have to write 1 and negative 1, 2 and negative 2, 5 and negative 5, 10 and negative 10. They're all the same thing, but mathematicians prefer the first way because the first way is shorter. Next, when it asks us to do synthetic division, finding a 0 of h of x, we are not going to plug and chug and try to find a 0 by guess and check. Remember, we are going to go and we are going to graph our function. Okay. So again, I use desmos.com/graphing. It's a graphing calculator. Entered our polynomial in our field at the left, and we can see that we have a lot going on in this graph. On the left-hand side, we have a touch and turn at -1. We have a cross at 2 and a cross at 5. So let's start with the 5 or the 2. We'll pick up that -1 in a little bit. So back to where we were. You can start with any of these. Okay. So let's say we want to start with x equal to 2. 2 will go in our loser corner. And then remember, we're going to take the coefficients from the order that's given. 1, -5, -3, 13, and 10. Give yourself some room. First one always goes to the floor, always goes to the dog. 2 times 1 is 2. Add vertically. -5 plus 2 gets us -3. 2 times -3 gets us -6. Add vertically, we get -9. 2 times -9 gets us -18. Add vertically, we get -5. 2 times -5 gets us -10, which means we got a 0 because this guy is 0, we know that x equal to 2 is a 0. And we also know that x minus 2 is a factor. We started off with an x to the 4th. And because we divided by x minus 2 or x equal to 2, we'll drop down 1 degree or 1 on our exponents. So then our remainder polynomial that we're looking at now is x cubed plus x squared. Oh, sorry. Try this again. Our remainder polynomial that we're looking at is x cubed minus 3x squared minus 9x minus 5. We're going to take this guy with us into the next part where it says find all other zeros. So if we're finding all other zeros, we had already found some in our graph. We had found x equal to -1 and x equal to 5. So if we're looking at that, we can use either one of those. Let's start with an x equal to -1. We would have a 1, -3, -9, -5. First one always goes down. -1 times 1 gets us -1. Add vertically, we get -4. -1 times -4 gets us 4. Add vertically, we get -5. -1 times -5 gets us 5, which gets us 0. We just found, because that's a 0, that x equal to -1 is a 0. And if we move the -1 over to the left by adding, we found that x plus 1 is a factor. Okay. Remember that we started with our remainder polynomial of x cubed, x squared, x, and our number, which means that we're going to have an x squared, an x, and a number, and then our remainder. This means that our new remainder polynomial is x squared minus 4x minus 5. This is our second remainder polynomial. Now to solve this, we cannot use square root property in this case because we have a middle term that's not 0. You could use the quadratic formula. You can use synthetic division still. Because we still have zeros on the graph. Or you can try to factor. And here, when we have x squared minus 4x minus 5, is that equal to 0? You would look for a product of -5 and a sum of -4, which means you would want -5 and 1. Which means that it factors into x minus 5 times x plus 1 equal to 0. We get x equals 5, x equals -1 are our zeros. And here we already found their factors. we said that their factors were x minus 5 and x plus 1. So when we're writing the factored form of our function, we can include these guys. We had x minus 5. We had x plus 1. I'm going to scroll up. We had another x plus 1 and an x minus 2. So I need another x plus 1 and x minus 2. But whenever we have 2 or 3 or 4 of something, you know how mathematicians are lazy. We don't want to rewrite this multiple times. So instead of writing x plus 1 twice, we say x plus 1 squared. If it was written 3 times, we would have a cube. If it was 4 times, we would have a 4th degree. But keep in mind that this means that our x equal to -1 had a multiplicity of 2, which is why when we graphed it, we had a touch and turn at x equal to -1.